Welcome to the Math Review. In this lesson, we're going to talk about representing percents in algebra. We'll take a look at these notes here, we'll answer these 4 examples, and then we should be good to go. So before we start trying to answer any of these questions, I know it says representing percents in algebra, and there are no variables here. Well, not yet. We're going to show you how it's similar when it's numeric to when it's algebraic. But before we do that, let's take a look at each of these notes. So here's note number 1. You cannot multiply a number by a percent. So I can't multiply 100% times 45. So what I would have to do is the following. We have to convert it to a decimal. So how exactly do we take this percent and convert it to a decimal? There's one of 2 ways to do this. Method 1, we can move the decimal point to the left twice. And the second, we can divide the percent by 100. Either way, if you divide the percent by 100, it's the same exact thing as moving the decimal point twice to the left. Now that we know each of these, let's take a look at each of our examples. Let's zoom in on this one here. So here we have 100% of 45. What we need to do is we need to take this percent and convert it into a decimal. Now, if we have 100%, right now the decimal is right after this number 100. Let's write that in. So right now, the decimal point is located right here. So in order to convert this percent into a decimal, I would have to take this decimal point here and move it twice to the left. 1, 2. And then I'll place it right here. So this will be rewritten as 1 whole. So this is really 1 of means times. And since we're dealing with algebra, well, we will be dealing with algebra, we should just use a dot to represent this. So we'll have of means times, that dot represents multiplication, and the 45 will just bring down. Now, how exactly does this relate to algebra? Well, it's pretty much the same idea. Instead of having a number, though, you'll just have a variable to represent that value that we don't know. Let's say we didn't know this was 45. Let's say instead this was A. So we're just saying 100% of A. So this would be 1 times A. And you would really just write 1 times A as just 1A. Or you could write it without the coefficient 1, and that would just equal A. Either of these is acceptable. So if we're talking about 100% of A, that would be represented as 1A. Let's take a look at the next example. So here we have 32% of 3,240. But again, let's say we don't know the value that's here. This still means 32%, which will convert to a decimal. This of means multiplication. And let's pretend that we don't know what this value is. Let's make it equal to C. So now we're going to write 32% of C. We'll take this 32% and convert it to a decimal. Remember, right now our decimal is right at the end of 32. So to turn this into a decimal, we're going to move it 2 places to the left. 1, 2. So now our decimal point is here, and we're going to rewrite it there. So it'll be, and we could put a 0 here if we want. We could put 0.32. This of means times, which we'll represent with a dot, and then we'll just bring down this variable C. And we'll rewrite this with this value here as the coefficient, and this is our variable. So our final answer is going to be 0.32C. And that is our answer for this example. Let's take a look at our third example. So here we've got 75% of 93.75. Again, we are just going to pretend that we don't know that this is 93.75. Instead of some value, we're just going to put a variable there instead. Because 75% is pretty simple. That would be 75%, we'll convert that to a decimal, times 93.75. The idea is the same, the only difference is we're using a variable instead. So let's change that, and let's call this value E. So now we're trying to find 75% of E. So we'll convert this to a decimal. This of means times, and then we'll bring down our variable E. So let's convert this percent to a decimal. This has a decimal point right here. So I'll take that decimal and move it twice to the left. 1, 2. That means my decimal is now located here, and I'll bring this down as a decimal without any of these markings. So we're going to bring down, and we can put a 0 here, and that would be 0.75. No more percent symbol, because remember, we turned it into a decimal. So this is 0.75. This of means times, which we'll represent with a dot. Don't try to put an x here, because x in this kind of lesson looks just like a variable. So stay away from that. And then we'll bring down e. And so now we'll rewrite this with this is the coefficient, and this is our variable. So our final answer is 0.75 e, or 75% of e. Now let's look at our last example. Here we have 5% of 1/5. The same idea is going to apply here. We're going to pretend that we don't know this is 1/5. Instead, we're going to call it some variable. Let's call it k. So now what we have is 5% of k. We'll convert this to a decimal by moving the decimal point over 2 places to the left. This of means times, and then we'll bring down our variable k. So let's convert this to a decimal first. Remember, here we have a decimal point right at the end of the 5. And since our decimal point is there, we have to move it 2 places to the left. 1. And now we don't have a value here, so we'll put a 0 there instead, and then we can move it over 2. This is where our decimal will land. And then we can put a 0 here. And we'll just rewrite it down here. 0.05 of means times, but we'll use a dot for that. And then we'll bring down our variable k. And we'll rewrite this with this value here, this decimal as our coefficient, and we'll bring down our variable right next to it. So when we write our final answer, it will look like this, 0.05k. And that is our final answer for this example. Thanks for watching our video on the math review. If you have any questions or comments, leave them down below. We might use your question in our next video. And if you found this lesson helpful, please make sure you like and subscribe to our channel. And it would really help if you share this and our other videos to any of your social media platforms. See you next time on the Math Review.